So this video is the first of a series of videos that's going to try to put it in a nutshell everything we've done in the course. And I'm really going to concentrate on some of the big ideas, the big takeaways, the things that I hope you've become more comfortable with in class. As is always the case when you study math, the details can really get messy from problem to problem. But I never wanted that to take away from your growing your understanding about kind of how things work and what things are trying to, how we're trying to represent things in formal math, even if every little detail of formal math is too much to handle in one course. So let's take a look at the objective. It's just to summarize our learnings about operations with real numbers and algebraic expressions. So this was spread out all throughout the year. You're going to get that sense as you look through this video. I hope you take the series pretty seriously, because it is this thing that is like, what can you take away from here, even if there were some doubts you still had. So first big idea, variables are used to hold the place of an unknown number. Some of you started the class by saying I was fine with math until letters started showing up, and it was almost like, what's the point of having letters? I hope that became a little bit more clear. Variables are used to hold the place of an unknown number. To try to illustrate that, an example, no variables needed here, because every chapter of a textbook contains 2 quizzes. How many quizzes are in the book if it contains 12 chapters? So this is an elementary school, middle school kind of thing. Depending on the student, they might go with plan A, where they would say, well, if there's 12 chapters and 2 for each, they think of repeated addition, 2 plus 2 plus 2 plus 2, they'd get 24 quizzes in those 12 chapters. But someone else might have plan B, which is, if I'm going to do 12 sets of 2, 12 repeated additions of 2, isn't that a job for multiplication? And they'd get 24 that way. All very good understanding. People walking into the class, I think, had that down. But when variables come into play, it's when you don't know the number of quizzes in each book, or maybe you don't know the number of chapters. When there's an unknown number, each chapter of a textbook contains some unknown number of quizzes. How many quizzes are in the book if it contains 12 chapters? Well, the 2 plans are still good. It's just that we're missing a piece of information right now, and that's where a variable comes in. So if there are Q quizzes in a book, an unknown number, but we just called it a letter for now, the strategy of plan A would be to add a bunch of Q's together instead of 2's. And for plan B, it would be to take 12 and multiply by Q to represent that I have 12 copies of Q, whatever the unknown number is. And what we did in this class was we spent a lot of time simplifying expressions, changing the way things look. And it's just because if I now look at plan A as a tool that is waiting for a use, like when we finally figure out how many quizzes there are, that's a messy looking tool. But if you know to add 12 Q's together and you get something called 12Q, because it is 12 repeated copies of Q, just like it is down below, 2 different ways, 2 different plans get to the same place, which is 12 times whatever number of quizzes it is. That takes us to the second big idea. Variable expressions, like 12Q, have an unknown values because they have an unknown in them. But once you know the value of the variable, then you can do some things we've done in class. We substitute the values in for the variable, and then we can evaluate an expression. If it doesn't have a value, we can't evaluate it. But if we have all the pieces of the puzzle, we can come up with the value for the expression, call that evaluate. So the expression 12Q gives the number of quizzes in a book if there are Q quizzes in each chapter. That's the kind of thing you read, especially at the start of this class, and go, who's wasting their time with that? But the idea is, we know that 12Q means something. It means the total number of quizzes in a book. There's an unknown in there because we don't know how many quizzes there are in each book, or in each chapter, sorry. But if someone comes along and says, how many quizzes are in the book altogether? If there's 5 quizzes in each chapter, now I have the piece of the puzzle I need. So Q quizzes in each chapter, 5 quizzes in each chapter. Okay, that means that 5 is Q. So where Q was in the original expression, 12 times Q, I substitute 12 times 5. So the 5 has been substituted in for the Q, and I evaluate, because now 12 times 5 is something I actually put a value on. So 2 big ideas there. Variables are used to hold the place of an unknown number, and then we can evaluate expressions once we've substituted in unknowns. Next big idea, there's an established order of operations for when there are multiple operations in an expression. In the expression 12Q, there was only one expression, it was times. But if there's multiple operations in an expression, then we have to have an established order, and we know that as PEMDAS. And here I separated it out because multiply and divide happen at the same time, add and subtract happen at the same time. So we've seen this come together for number and variable expressions. I could ask you to evaluate 40 plus 2 times 4 minus 9 squared. And I don't know what that used to look like to you guys. But the word evaluate might be something you had some doubts about. But evaluate means put a number value on it. stop with this 40 plus 2, blah, blah. It's a really mess. What's the number value for that thing? We want to evaluate it. But since there are a lot of operations there, we don't have to get overwhelmed. We can think through PEMDAS. And at this point, I want to point out that add and subtract always comes last. So I hope that as this course developed, you, like I have, start to separate out that addition as like kind of a more like, hey, that's on the back burner because that always happens last. So now you're not tempted by that 40 plus 2. If you can visualize that adding and subtracting always comes last, 40 plus 2 isn't even on your paper because 2 has to be times something first. And even before that happens, we have to take a look at the parentheses. So inside the parentheses is 4 minus 9, and we can still trip up over 4 minus 9, whether it's 5 or negative 5 sometimes, but we know inside the parentheses has to happen first. In this case, it's a negative 5. Okay, parentheses is done. Let's move on to exponents. I see an exponent, it's that little 2 there, and that means negative 5 times itself. And a negative times a negative is a positive, so it'd be a positive 25. And the other thing we've worked on a lot in this class is making sure you can keep writing equivalent expressions so that if this was given to us originally and we wrote this line down, everything's there so that people can tell this line is equivalent to what we had before. One little thing is happening at a time so we can maintain equivalence. What's the next thing that has to happen here is the multiplication and division. Notice how that add and subtract is still kind of waiting on the back burner. 2 times 25 has to occur, becomes 50, and now finally we can get to the add and subtract and we get 90. So we just evaluated following the order of operations. I hope that's something you've gotten better at this year. And the last piece for this video is a concept that, or a big idea that concepts such as like terms and exponents, they're the reasons that we use when we're simplifying variable expressions. So we're moving back onto variable expressions where there's an unknown. And I'm not going to hand you a value of m to use here, so we can't evaluate this expression. But we can simplify it. And that's just another application of PEMDAS. So we have to take a look at this expression the same way we did the other one and think, well, adding and subtracting always happens last. So let's kind of break it out there. I see 2 times something plus m times something. And the plus is going to be that, we'll do that last. So I can now concentrate on the rest of it. I can look at inside the parentheses. Now at this point, I highlight the phrase like terms because inside the parentheses in the last problem was 4 minus 9, something we could simplify. In this expression, 3m plus 3, they're not like terms. And when we're adding and subtracting, they really need to be. M minus 4, again, m and 4 not like terms. So we have to actually go right on past the parentheses. There's nothing to do inside the parentheses. So we would look for exponents, of which I see none. I could see multiplication, division. And this brand of multiplication, when you have unlike terms, is this property called distribution, a distributive property. Meaning that if you have to do 2 times this quantity that you can't piece together, 3m plus 3, if you have to do 2 times something that is made up of 2 terms, double this term and double that term. So that's the idea of distribution, and we're going to see that happen. I want to highlight this one here because m times m is a time that we have to use exponents. Remember, exponents show you multiple copies multiplied together. Variables that have been multiplied by themselves. So that means it will multiply here. It looks like I'm about to make 1, 2, 3, 4 terms, and that's going to be a 6m, a 6, an m squared, and a minus 4. And again, see that exponent showing up. Okay, so I am now through the multiplying and dividing, and I can now concentrate on the adding and subtracting. And the idea that adding and subtracting happen at the same time from left to right is going to kind of show up in the fact that every term has its own sign. And if you can order those terms together, especially like terms like the 6m and the negative 4m, those are going to combine. And then we tend to put higher exponents first. So I see an m squared term that's unlike any other. I see my like terms coming together to make a 2m, and then I see my 6 at the end. So evaluating and simplifying are very similar. They're applications of PEMDAS. It's just that one is when you're going to get a number answer, and one is when you get a cleaner equivalent expression that it's a little bit nicer to look at. So that's the end of this first video. I'll give you a problem set to work on that's going to take you all the way through everything we've done in the course, and then I'll see you tomorrow with a new video.